Today we're going to talk about how to install the DRV8825 and the A4988 on the MakerBase MKS Robin Nano version 2.0. On the back of the MKS Robin Nano, as you can see, there's a little key that they give for what you need to set for jumpers. So as you can see right here, they have their UART mode jumpers, then they have their SPY mode jumpers, and then they have their Step DIR set of jumpers. So now that we understand how to set up the jumpers, the other thing that we need to understand is where the enable pin is located for each one of our steppers. So I'm going to zoom in to show you this. So as you can see on this zoomed in picture on the back of your silk screen of your MKS Nano Robin, you can see that they have an N located right here. That's your enable pin. Over here, they have your direction pin, and then they have your ground pin located over in here. So it's kind of hard to read because there's not an EN, but there's an N, and that gives away the position at which we need to set up our Step DIR. So to overemphasize yet again, the enable pin is actually located here, 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 and here. So what we're going to do is we're actually going to set the jumpers now. So now we're going to set the jumpers now that we know what the jumper pins are. So I'm going to place the first one right here and push it down. Then I'm going to take the next one. And what this does is it increases the amount of rotation that we're allowed with our steppers. So I'm going to place the other one right there. And then the final one goes right here, and that takes care of our X steppers. So now we're going to do the same for our Y steppers. We're going to place one right here. And we're going to place another jumper right here. And if I haven't already told you this, the DRV8825 does 1/32 of a step for its maximum step, and the A4988 does 1/16. But that's how your jumpers should look once you've connected them up. So now I need to take a moment to explain the A4988. If you haven't figured out already, in the very center it says 4988. That is actually our Step DIR, or the brains of this board. So now we need to figure out where the enable pin is. And the labeling for the silk screen on top is not very good. So I'm going to flip it over so you can see the bottom. As you can see on the bottom, it does say enable, and the pin is located right here. And that's the one that said N on the actual silk screen that we were looking at. As you can see, the direction pin is located at the other end right here. And then, of course, you have your ground pin right here that give you the actual lay of the land for this actual step driver chip. So now we're going to talk about the actual DRV8825. And if you haven't guessed yet, there is a marking on the chipset as well for the integrated circuit that says DRV8825. And now we need to figure out where the pins are located for this as well. So here's the underside of the DRV8825. As you can see in the upper left-hand corner, the pin says EN for enable. And then in the far right-hand corner, you can see DIR for direction. And below that, in the bottom right-hand corner, you can see the ground pin. So now that we know where the enable pin is located, now we can plug these in. So what I'm going to do is I'm going to start with the A4988, and I'm going to rotate it over to verify where the enable pin is. As you can see, it's by my index finger. So what I'm going to do is rotate this over, and I'm going to place it over the connection, and then apply a little bit of thumb pressure to put it in place. Now I'm going to do the exact same thing for the DRB8825, where I'm going to rotate it over, verify where the enable pin is, and then place it in the board as well, applying a little bit of pressure. Now there's a couple of things I didn't point out initially that will help you make sure that you also are putting these in correctly. So to start with, on the A4988, you can see that there's a trim pod here. This is used to adjust current. That will help you tune these with a multimeter. The same is true for the DRB8825, which is located right here, and that'll allow you to tune it as well. Now I have made other videos that I'll leave a link in for the DRB8825, and I'll put that in the upper right hand corner, and then I'll put the other link in the description of the video, and you can see what the process is for tuning those. Okay, in order to set this up to be programmed, what we need to do is remove the SD card, and this is a 128 megabit SD card, and place it in the adapter like so, and then place this in your computer. Okay, the first thing that I always like to show you is the SD card, and as you can see, inside here it says Marlin_nano35.cur. Now, it's in all capital letters, which means that it's already been loaded, and the cur means current, for the current firmware load. And this will become more relevant in just a moment. So what I'm going to do is I'm going to go over to the Marlin website, and I'm going to download the current firmware. So the current firmware that we need to work with is a 2.0 version, because it is a 32-bit board. So I'm going to click on this and let the download complete. But I'll show you that there are other builds, but these are for 8-bit processors. And then down here, there's a couple of things that you need to understand. Over here, this is bug fixes for previous build releases where they actually make a fix. And they do the same thing for the 2.0 version. They also do development in the bug fix. So you might see this change to 2.1 in a couple of days. It basically follows the year. So now that that's completed its download, I'm going to go to the folder, and I'm going to right click, and I'm going to click on extract all, and then extract. Now this may take a few moments, but what we're actually doing is we're extracting all of the Marlin firmware. And I did discover a change that I didn't realize in the first tutorial, having to do with this serial port. So this is going to be kind of important. One of the serial ports that I specified as the number 3 for the second serial is actually usable on the first serial port reference. This is something I discovered later on. When this first came out, it was somewhat new, so I wasn't able to get that detail, but now we have it. So I'm going to go over to VS Code, and what we're going to do in a moment when this finishes extracting is actually open the folder. So I'm going to go over to VS Code, I'm going to click on the Explorer, then Open Window, or Open Folder, pardon me. I'm going to go to my Downloads folder. I'm going to click on the first Marlin folder, then the second Marlin folder, then Select Folder. And this will bring up the environment for VS Code with platform.io.ini in it. So once this is finished, what you want to do is click on the Marlin folder, then the source folder, then the core folder, then boards.h. Inside boards.h, we're going to do a search on Robin. And down here are all the processors that we need to worry about, but the one we're looking for is actually this one right here. And this is our board definition. So we're going to copy this. And then we're going to close out of boards.h. We're going to minimize the core folder, the source folder, and we're going to click on configuration.h. Now we're going to search on motherboard, and we're going to highlight the motherboard that's currently here for the ramps and paste over it with what we just copied. Then up here, instead of changing this to the number 3, we're actually going to do it right here. So we're all set with that. Now we need to set up our steppers. So I'm going to do a search on the A4988. And we have two different steppers that we're worrying about, and that's the DRB8825 and the A4988. The A4988 is actually a 16 increment step, whereas the DRB8825 is 32 increments. So I'm going to uncomment the X and the Y for those. I'm going to do Z for good practice. And I'm also going to show you where the E0 is. This would be your first extruder. So what we need to do to make changes here is actually copy the DRB8825 and put it on our Y axis. And once this is done, what we also need to worry about is this one's going to be inverted in comparison to this one for direction. So let's search on invert and see if we can find it. So there's a way to invert the steppers to actually go in the opposite direction. So what we're going to do is, it says right here, for inverting stepper enable pins active low. That could be what we're looking for, but we also have invert stepper direction down here. So what I'm going to do is I'm going to change the Y direction to false and see what happens. Otherwise, it's probably going to be something up here. So now we need to look for basically the A4988 so I can navigate back to something for a second. So down here, we need to configure the default axis steps per unit. And right now they're defaulted to 80 for the X, 80 for the Y, 4000 for the Z, and then E0 is set to 500. Now I've made videos on how to calibrate the actual E steps for your extruder. I'll include a link in the upper right hand corner. And I'll show you what the process is to actually figure out these values, how they should work, although it can vary. So I'm going to go over to my browser for a second, and I'm going to search on RepRap calculator. And I'm going to go to the first link that comes up and show you what's going on with X and Y. So this is steps per millimeter, and it's a belt-driven system. So that would usually mean your X and your Y axes. So the first one that we have is the A4988. And we're going to make an assumption, although you can change these values, that we're working with 1/16 of a step, and we have a GT2 belt, which has a 2 millimeter pitch. So the value technically would be 200, assuming that all these things are true. Now you can vary them depending upon what you're working with, and I'll show you how to do that in just a second. So I'm going to go back to over here for my X and change this to 200. Then I'm going to go back to the browser, and because we have the DRB 8825, we need a different value, which is 400. So I'm going to copy that and go back again, and then I'm going to paste that value in as well. So we're not going to worry about the Z. That's a little bit further in the RepRap calculator, and you can look that up yourself. But what we're going to do now is we're actually going to set up the compile. So we have to go over to platformio.ini, and we have to search for our default environment because this is not our chipset. So I'm going to search on Robin, And down here, we're looking for the nano. So the only one that has nano in it is right here for the environment. So I'm going to copy that. And then I'm going to go back to the top. And where it said default environment, I'm going to paste what we just copied. And then I'm going to compile it by clicking this checkbox. It's also known as build. But before I do that, I want to clean everything out. So I'm going to click on this garbage can. And this basically does a clean of what was in the .pio folder. So that's pretty much cleaned out, although it doesn't look like it, as you can understand. What we can now do is click on the actual checkbox to do the build. Now, there may be failures that occur. I've noticed that I've had to compile twice on occasion using the checkbox, but we'll see what happens and how it turns out. Okay, as we can see, it was actually successful on the first try. So to load this, what we need to do is go to the .pio, then we're going to go to the build folder, then we're going to go to the MKS Robin Nano folder, right click, and we're going to go to Reveal in File Explorer, and we're going to have to go one folder deeper. And as you can see right here, we have the Robin_nano35.bin. Normally it would be firmware.bin for other boards, but in this case we need to copy this one and send it to our SD card. Now I'll show you the contrast between what I started with. The bin is the one that's the binary that's going to load, and this is the current. So this one eventually will turn into this one if your build loads correctly. If you do have an issue where you don't have a bin file and you need to revert back and you only have a cur where you need to reload it, you can always rename this to this and it'll reload like normal. So I'm going to take out the drive and install it now in the Robin Nano. Okay, I've wired up a couple of things obviously, and not wired a couple of things, being the power supply. So I'm going to show you first how to install the card. So I'm going to take the card right here for the SD card, which is 128 megabits, and slide that in. Next, I'm going to double check my jumpers over here so they're on the first two pins, because we're going to use direct power for this. So I'm first going to install this over here into here. Next, I'm going to take my ferruled connectors. This is what I use to actually make them safe so that the wires are encapsulated so you don't get a stray wire. And the tool that I use that for is the ferrule tool, which is right here. But let me just tell you one thing while I'm working on this. I'm going to release these screws, show you how to install it. Notice how I put a red mark on one and no mark on the other. That stands for voltage, and this is ground. That's just so that I don't plug into the wrong thing. And then I match the wire coloring for the red. Now, I also have to explain to you that this board was provided to me by MakerBase, but the other parts in this tutorial, I'll include a link in Amazon affiliates where you can purchase those. And no one is paying me to do this tutorial. So now that we have that hooked up, in order to actually load it, we're going to take our power and plug it in. And this will load the firmware for us. Now, keep in mind this system is actually under power, so you don't want to touch it. But I want to show you these real quick. These are actually the cooling fins that you would place over the black chips. For now, I'm leaving them off for this tutorial, but normally they should be placed on top of them. Okay, now that we have the firmware loaded, I went to my print run directory to open up Pronterface. I'm now going to connect to the board, and as you can see, it says connecting, printer is now online. So we know that we have the X and the Y installed. So what I'm going to do is I'm going to move the X 10 steps and see what happens. Now I'm going to move the Y 10 steps and see what happens. And they move pretty close to the same. So we know that we have them somewhat closely calibrated. We can do a little bit more in-depth calibration. I've made a video on how to calibrate both the A4988 and the DRB8825. And I'll leave a link in the upper right-hand corner so that you can figure out how to do that. And I'll leave one in the actual description. So let's try moving the X stepper 100. Pardon me, that's the Y stepper. And now we'll move the X stepper 100. So if you like my tutorial, please press the like button and subscribe. And thank you for your time.